All right, guys, welcome back for lecture video number 2 here for chapter 6. Moving right along now to talking about mass and the mole. Obviously spent some time last class and with last lecture video talking about the comparison of moles and particles, right? And this idea of that whenever we're thinking the word mole, we should be thinking 6.02 times 10 to the 23rd particles of that, right? Whether it's particles or atoms or ions or molecules, whatever, right? Those are all interchangeable words with each other, right? But what about if we're comparing moles to the mass of something? Now, I had someone in class the other day mention to me and say, hey, Mr. Sarah, well, if I have 1 mole of a certain element, I believe the element that was mentioned was nickel. If I have 1 mole of nickel, is that a lot of nickel? Do I have a lot of nickel, like physically? Right, nickel being Ni on the periodic table. And my answer to him was actually no, right? And the reason why that's the case is even though 1 mole of a substance is 6.02 times 10 to the 23rd particles of that substance. So if I have 1 mole of nickel, I have 6.02 times 10 to the 23rd particles of nickel. That's a lot of particles, right? 6.02 times 10 to the 23rd particles of nickel is a lot of molecules of nickel. But the thing is, each of those individual particles or individual molecules of nickel are so incredibly tiny and small that they're almost like not nearly as large as you might think that is. And this idea of mass and the mole comparison is going to kind of help us ground these ideas of the mole and particle to help us ground it in something more reality, right? Something that we can kind of measurably see, right? Because we think more so, our brains think more so in terms of mass as opposed to moles and molecules, right? So let's kind of make that comparison today right here. Starting with something basic, right? Going back to donuts, right? Mr. Sarah loves his donuts, right? How much does a dozen donuts weigh? Let's say, arbitrarily, a dozen donuts weighs 1,800 grams. Okay, 1,800 grams. Plain and simple. Again, we're obviously going to be using grams, not pounds, not ounces, anything like that, right? 1,800 grams. Okay, so that means that if we take 1,800 and divide by 12, we're about 150 grams, right? So 1,800 for a dozen donuts. Well, if we want to find the weight of 1 donut, it's 1,800 divided by 12 to get us the mass of 1 donut. It's about 150 grams, okay? Keep that in the back of your head right now. Same with a dozen candy bars. Let's say a dozen candy bars weighs 2,400 grams. Same thing, 2,400 divided by 12 to get us the mass of 1 candy bar, 200 grams. Keep that in the back of your head. So 150 for donuts and 200 grams for a candy bar. Now, if we think of this in terms of moles, how much does a mole of 1 donut weigh? Well, if I had a mole of donuts, well, I'd have this many donuts. And quite simply, guys, we got that by multiplying that 150 from the first bullet point there, right? 150 being the mass of 1 donut, right? And if I had a mole of 1 donut, essentially that's going to be 150 times that 6.02 times 10 to the 23rd. And that's going to get us exactly 9.03 times 10 to the 23rd. Essentially moles or grams of that particular thing, right? That same thing is extended to a mole of 1 candy bar, right? Same deal. That 200 grams times 6.0 times 10 to the 23rd power is going to get us 1.204 times 10 to the 26th grams. Now, okay, running back, moving away from food items, right, from donuts and candy bars, right? Let's think about this now in terms of actual chemistry, right? How much does a mole of H atoms or hydrogen atoms weigh? Well, that's simply going to be 1 gram. Well, where the heck did that come from? Well, let's think about lithium now, okay? How much does a mole of lithium atoms weigh? Well, that's actually going to just be 6.94 grams. Well, where am I getting these 1.0 grams and 6.94 grams from? Well, plain and simple, guys, they are the formula masses, the atomic masses we see on our periodic tables, right? Not just plucking these numbers out of thin air. These are the amount of mass in 1 formula unit of an element or a compound, right? That's essentially what formula mass is. It's going to be a new thing that we're going to learn how to calculate today in this lecture video. That's going to help us out when I see you guys next for class when we do some conversions between moles and mass here, okay? But again, the formula mass for each element is, of course, listed on the periodic table as atomic mass. So if you see, obviously, this is a key that's in the top middle of your periodic tables and your reference tables, guys. Obviously, carbon being our go-to example oftentimes, right? And this key is very clearly showing atomic mass in the top left-hand corner of your reference table being 12.0 grams in this case. Okay, so that is where I'm getting these masses from. Just like I had here for 1.00 grams of H, well, if you take your reference table, specifically your periodic table, and you go in the upper left-hand corner for hydrogen here, right? Hydrogen, 1.00. Well, 1.00 grams is how much 1 mole of hydrogen weighs. Same with lithium. Lithium is just below that. Lithium, top left-hand corner, 6.94 in the upper left-hand corner for lithium on the periodic table. Well, our answer for how much a mole of lithium atoms weigh, 6.94 grams. Okay, so we get that from the periodic table. Right, it's as simple as that. Now, when it comes to some of these words here, guys, just like previously in our last lecture video where I said if you see the word particles or molecules or ions or atoms, right, any of those 4 words were pretty interchangeable with each other, right? So if you had, 6.02 times 10 to the 23rd atoms or particles or ions or molecules, those all meant the same thing. That's going to be the same case here, but for a different type of phrasing of something. So all of these words here, gram formula mass, formula weight, gram formula weight, molar mass, number of grams per mole, atomic mass, average atomic mass. Anytime you encounter these words and phrases here, guys, they all mean the same thing. They all essentially mean gram formula mass, the mass that you see in the upper left-hand corner on the periodic table, just like you see here for carbon, and just like you see for basically every single element on the periodic table. Okay, so it's pretty common practice to look at the masses on this periodic table here and be able to determine that they all mean the same thing. So all of these words here, all these phrases here, all mean the same thing. They want you to look in the upper left-hand corner for the particular substance in question, whether it's carbon or hydrogen or lithium, whatever it may be. Now, this idea of gram formula mass, it refers to the number of grams of that substance in 1 mole of that substance. So it's equal to the formula mass. Okay, so the units for this idea, this concept of formula mass, are going to be this grams per mole here, this G/mol. It's pronounced grams per mole. So really simple here, simple calculation for our very first gram formula mass calculation. We're asked to report and calculate the gram formula mass of NaCl. Well, where the heck did I get that from? Okay, it's actually pretty simple here. Okay, so we go to the periodic table. We're talking, of course, about NaCl, right? One of our classic examples. Whoopsie, wrong color. One of our classic examples here of NaCl right here. Okay, so NaCl is what we are referring to. And so I'm going to be taking a look at my periodic table and finding Na by itself, because Na by itself has a mass of 23.0 grams. Cl by itself has a mass of 35.5 grams. Well, if you add these up, right, because of course we're talking about the compound NaCl, it's going to be the addition, we're adding these together, right? If I have 23.0 grams plus 35.5 grams, 3 plus 5 is 8, 0 plus 5 is 0.5 grams, 58.5 grams, which just so happens to be what we have here. But it's not just grams, it's grams per mole here, right? Because we're talking about the number of grams for every 1 mole of that substance, right? Which brings into the fold, guys, the idea of these unit equalities, right? Remember unit equalities where you set 2 different measurements equal to each other, right? Just like 1 foot equals 12 inches, right? This is a unit equality, right? 2 different measurements, feet and inches, with 2 different numbers, 1 and 12, setting them equal to each other, because for every 1 foot, you've got 12 inches, 2 different measurements, 2 different numbers here, right? It brings into the question, how do we understand this idea of the unit equality whenever we're talking about gram formula mass? Because if you haven't noticed, the gram formula mass, the number of moles, right, essentially, are different based on whatever substance you're talking about, right? This 58.5 grams per mole is very, very specific to the formula NaCl. If I had a different formula, right, maybe LiCl, right, that's going to totally take in a different perspective, because the mass of lithium, Li, is different than the mass of sodium, right? Even if it's combined with lithium and chlorine, it's going to totally be a totally different grams per mole. Right, and again, that's going to bring into the fold this idea of these mole mass conversions, right, and how we go from our unit equality, right, to these now conversion factors, these two fractions, right? So in order to convert between moles and mass, our goal here is to calculate the formula mass, write the two conversion factors, and use dimensional analysis to solve, right? Those 5 different steps we went over in class the other day. So first and foremost, we write our formula mass, right? So whatever that ends up being, because again, it's 1 mole equals the gram formula mass. And I'm going to essentially use GFM, gram formula mass, as like a basic way of kind of showing what I mean by that, what I mean by gram formula mass here, okay? Whoops. All right, so now that we have our unit equality, 1 mole equals the gram formula mass of that substance, I can take this unit equality and create my two conversion factors, my fractions, right? So I'm basically taking these two things here, this 1 mole and this gram formula mass, and creating fractions based off of my two measurements here, right? So our two conversion factors here, first and foremost, are going to be 1 mole divided by the gram formula mass of that substance, or again, depending on what you're trying to solve for here, right? Because obviously every dimensional analysis problem is different. Or we just do the inverse of these, right? Moles go in the bottom and gram formula mass will go in the top here. So now it switches to have GFM in the numerator because you just swap them. GFM, gram formula mass in the numerator, and 1 mole in the denominator, right? And again, of course, this idea of gram formula mass is going to be different based on whatever substance you're dealing with, right? If you're just dealing with one, specific substance, maybe just carbon, for example, right? This gram formula mass is not going to just be GFM, right? If we're dealing with just carbon, we go to the periodic table. Carbon tells us we've got 12.0 grams. So this was going to become 12.0 grams. Okay, but again, if we're not talking carbon, this is obviously going to be different based on whatever substance we're talking about. Let's say we're talking about nitrogen. Well, 1 atom or 1 mole of nitrogen is going to be equal instead now to 14.0 grams of nitrogen. Okay, so again, it's very, very, very specific to whatever substance we're talking about. So I'm going to backtrack here, get rid of all this, and get our gram formula mass back. So again, it's all based on the actual gram formula mass that we are going to calculate. And again, we're going to do a bunch of examples of calculating gram formula mass in class when I see you guys next. But moving on to our last slide of the day today is our third and final type of conversion with moles, and it's moles and Von. All right, so we've obviously tackled moles to molecules, right? 1 mole equaling 6.02 times 10 to the 23rd. Molecules, atoms, ions, whatever, right? And we just finished talking about moles and grams, right? Converting between moles and grams. So 1 mole is equal to the gram formula mass of whatever substance you're dealing with, right? If it's just carbon, it's 12 grams because that comes from the periodic table. But if it's carbon plus something else, right, well, you're adding all those masses together, right? To our last one here, our third and final one, which is moles and volume. Now, this is basically probably the easiest one because it doesn't require an extraordinarily large number like 6.02 times 10 to the 23rd. It also, like mass, doesn't require the use of a secondary calculation, right? Calculating the gram formula mass of your substance and going to the periodic table and adding up all the things together, right? Accounting for subscripts, all those good things, right? It just is 2 numbers, 1.00 moles and 22.4 liters. That's it. Okay, that is it. So basically, guys, the conversion or the unit equality here actually takes these two guys right here, 1.000 moles and 22.4 liters. So the actual unit equality is 1.000 moles equals 22.4 liters. Okay, so that is the actual unit equality where you're setting two things right equal to each other. Again, 1.000 moles equals 22.4 liters of whatever we're talking about. And generally speaking, this is liters of some kind of gas here as well. Now, of course, we take those two things, that unit equality, to create our two conversion factors, right? So here again is our unit equality of 1.000 moles and 22.4 liters. And we just take those two measurements and create a fraction of them, right? Putting 1 in the numerator, 1 in the denominator, and then swapping for the second one, right? So our first one here would be on the left, 22.4 liters in the numerator with 1 mole in the denominator. And in order to get our second one, we swap those positions to have 1 mole in the numerator and 22.4 liters in the denominator. And that is excuse me, that is it for our moles and volumes calculation. And again, all 3 of our mole conversions right there. End of the video. I'll see you guys in class. Take care.